Here we are again. We are jumping into lesson 20. We're going to start taking a look at relationships between numbers and patterns between one number and the next, and how that can help us out in math. So we're going to start with Miss Maria. She's working at a snack stand at a basketball game. Each frozen yogurt costs $3 and each sandwich costs $6. Create a table to show the cost for buying 0, 1, 2, 3, 4, 5, or 6 frozen yogurts. Create another table to show the cost for the same number of sandwiches. How does the cost of a given number of frozen yogurts compare to the cost of the same number of sandwiches? Now, this is where I would lose you. If we were in class right now, I would have only shown you a slide that had just this problem on it, because I really firmly believe that we could bust out those dry erase boards right now and you could create some tables to show me what the cost would be, and you can see down below that they already gave it away, which the slideshow wouldn't have. But they created a table that showed the number of yogurts that you're going to buy and the cost that it would be for that many frozen yogurts. They did the same down here for the sandwiches. This question, how does the cost of a given number of frozen yogurts compare to the cost of the same number of sandwiches, is usually where I lose you. That's often because we haven't really thought about the problem yet, and we're trying to figure out how to answer a question. Can't answer a question without giving it some thought first. If somebody says, "What are you going to do tomorrow?" Generally, you're going to sit and think for a second before you give an answer. Same thing goes with math. So let's see how they walk us through this step by step. Letter A. What is the cost for buying one frozen yogurt? So if we go up into our original problem and find the frozen yogurt costs $3 each. So we're going to say that one frozen yogurt is $3. What do you add to the cost of one frozen yogurt to get to the cost of 2 frozen yogurts? So in other words, if one frozen yogurt is $3, what are you going to add to that to get another frozen yogurt added onto it to make it 2? You're going to add $3, right? We're going to go up by 3. So if we're going to go up by 3 each time, they want us to go ahead and complete the table. If we didn't have any frozen yogurts, we didn't buy any, the cost would be $0. If we bought 1, the cost would be $3. If we bought 2, that's the original $3 plus another $3. So we're going up by 3. So that would be $6. If we wanted to buy another one, we would add 3 again. So each time I'm doing a plus 3. 4 of them would be another plus 3. Another plus 3. And another plus 3. Which you'll also find this is the answer to 1 times 3, 2 times 3, 3 times 3, 4 times 3, and 5 times 3, and 6 times 3. Okay? All right, so let's move on to sandwiches. What do you add to the cost of 1 sandwich to get the cost of 2 sandwiches? Well, if I go back up there and take a look, it shows me that sandwiches cost $6. So 1 sandwich is $6. So what do I add to that 1 sandwich to make it 2 sandwiches? I'm adding $6 each time. So 0 sandwiches, $0. 1 sandwich, $6. 2 sandwiches is another plus 6. So we have 12. 3 sandwiches is another plus 6. 18. Plus 6. Plus 6. Oh, whoops. Oh, $13. See, I can't talk and write at the same time. I knew something looked wrong there. 18 plus 6, 24 plus 6, 30 plus 6, 36. And we go back to it being the same thing, that these are all multiples of 6. Because remember, a multiple, this would be 1 times 6. The multiple is 6. 2 times 6, 12. 3 times 6, multiple. So these are multiples of 6, meaning if I count by 6s, this is my order. Now, how does the cost of sandwiches compare to the cost of the same number of yogurts? Here's where you're answering that question from up above that you thought seemed tricky. All they're doing is they're asking you to compare what's the cost if you buy 1 yogurt to the cost if you buy 1 sandwich. How would you compare 3 and 6? So we're starting with that. How would you compare the number 3 to the number 6? I want you to think about that for a second. Let's look at if we had 3 yogurts. Let's say we bought 3 yogurts and 3 sandwiches. Now we would be comparing 9 and 18. What if we went up to 6? 6 sandwiches is $18. Or I'm sorry, 6 yogurts is $18. 6 sandwiches is 36. What about the 2? 6 and 12. You notice anything about these? I hope you've noticed that if you buy this many yogurts and that same amount of sandwiches, what are you paying for the sandwiches compared to the yogurts? If you double 3, you get 6. If you double 9, you get 18. If you double 6, you get 12. If you double 18, you get 36. So the cost of the sandwiches will always be double the cost of the same number of frozen yogurts. Meaning, if I'm going to buy four frozen yogurts, if I bought 4 sandwiches, that cost would be double what it would cost me for 4 frozen yogurts. If I bought 3 frozen yogurts, whatever that cost is, that would be double if I bought 3 sandwiches. Okay? Because the cost of a sandwich is double the cost of a frozen yogurt. So it doesn't matter however many you buy. If you buy that same number of frozen yogurts to sandwiches, the cost of sandwiches will always be double, or the yogurts will be half the price of the sandwiches. Okay? Let's take a look here. The cost of frozen yogurts and the cost of sandwiches form numerical patterns, which we showed you. Up by 3, up by 3, up by 3. Over here we have up by 6, up by 6, up by 6. You can use a table to write ordered pairs. An ordered pair is a pair of numbers. Now, you learned this several times this year, boys and girls. One of them was at Starbase. Do you remember when you played like a battleship game at Starbase? This is just like Battleship. Ordered pairs, remember, they work off of those axes. Just like when we did those mystery puzzles, and you would get a 2, 3. That would be a positive 2, 1, 2, and you go up positive 3, 1, 2, 3, and you go up and you put a dot. Remember that? And then you could start to connect the dots to create a picture. That was an ordered pair. So that's what these are in your chart. Okay? So it says you can use a table to write ordered pairs. An ordered pair is a pair of numbers. Ordered pairs can help you see the relationships between corresponding terms in two patterns. For these ordered pairs, the first number is the cost of a certain number of frozen yogurts. So over here we have the yogurts, okay? And over here we have the sandwiches. So what they're doing is they're showing you the ordered pairs are comparing basically the two numbers by putting them together. So if you had one frozen yogurt, it would be $3, and one sandwich, it would be $6. Two yogurts would be $6, and two sandwiches would be $12. Three yogurts, $9, three sandwiches, $18. So as an ordered pair, those are the way that it comes out to look. There's a relationship between the first two numbers of these ordered pairs. Here, the second number is always twice or double the first number. So look, 30 is double 15. 24 is double 12. Because the cost of a sandwich is double the cost of the yogurt. All right, let's take a look at the reflect. What if the ordered pairs were written as 0, 0, 6, 3, 12, 6, 18, 9, 24, 12, 30, 15, 36, 18? I want you to take a look at that, boys and girls. The numbers that they just listed are the exact same numbers that are listed in this table, but what do you notice? 6, 3. If you go up here, it was 3, 6. 12, 6 was 6, 12. So would this change the relationship between the first two numbers, or between the first number and the second number? Let me ask you a question. Is the relationship, or how these two numbers are connected, if it's 3, 6, and in the new one down here in the reflect, it's now 6, 3, is the relationship between these two numbers the same or different than the relationship between those two? Here's what they told you. In this one, the second number is always twice or double the first number. Is that the same here in the new ones they're giving us? It is not. The relationship between the new ordered pairs is different. Because the second number in the pair is no longer double the first number. You see that? 3 is not double 6. Instead, the second number in the pair is half the first number. See, 3 is half of 6. Over here, 6 is double 3. Okay, when you go from 3 to 6, it's doubled. But when you go from 6 to 3, it's half of. So the relationship is not the same anymore because the order has changed. And since the order has changed, it's no longer, the second number is no longer double. The second number is now half of the first number. Okay? You're going to try to analyze some relationships on your practice page yourself this time. So you are going to turn to page 213 and 214. in your practice book. You're going to complete those and send me a photo of your 2 pages when you are all done. All right, boys and girls, I will go over these with you in your video on Thursday. Have a great science day on Wednesday.